Hello, everyone. Hey, welcome back. Excuse me, I've got a frog in my throat here. Welcome, everybody, to the September meetup. Hopefully, everybody's been having a good time away. Anyway, let's go ahead and we'll still got a few more people probably logging in here. So we'll go ahead and get started. Excuse me. Anyway, on behalf of the St. Louis Go Steering Committee, I'm Paul Baylog, and then I'll be your host. And then we've got Sabri Blackman. I don't think he's online with us just yet. Brandon Hunter, I think he's MIA at the moment as well. And then Siju John, which I see he's already made it. So, yeah, we know who the slackers are in this group. So, anyway, but again, welcome to our little group. And I'd like to thank our sponsors. First of all, GoBridge for gathering or taking care of the meetup fees associated with meetup. And the CNCF also for taking care of the fees for the Crowdcast, the streaming platform here. So, and as with both of these groups, they do actually have the code of conduct. So I've listed them both here, but basically just, be a good person, be excellent to each other, and then we'll all be fine. So we go, sorry, there we go. All right, so we'll start off with some announcements here. Yeah, the big news is I went ahead and I picked up the STLGo.org domain, top level domain, and I set up a couple shortcuts. So now you don't have to remember our meetup URL. You can just do STLGo.org and /meetup and go straight to that. And I've also set up I've tweeted this out, but we've got a YouTube channel now. So I've exported all the videos from the sessions. Oh, there's Sabri. And then they're all now available in YouTube. The only unfortunate thing about it, though, is that on the export, I found out that you lose all the chat. So none of the chat that we talk about there on the side makes it over to YouTube, unfortunately. But probably next month we'll try doing it where we actually stream from Zoom straight into YouTube. So we'll probably do that. Had some last minute stuff where I wasn't able to get all that together for tonight. So we already paid for the Crowdcast license. So yeah, might as well use it. So other big announcements, and this is kind of the continuing thing. Actual GopherCon is going to be virtual again, or not again, but will also be virtual, as is everything else. They had the $100 community ticket, and then they also have some diversity scholarships and that you can sign up for if you're interested. So that should be a pretty interesting one. I actually need to sign up for this one. I don't want to forget. And then following that is the KubeCon North America. We're lucky enough to attend the European Union one. That was actually pretty cool. It went pretty well for a virtual event. Wasn't too bad. And this one I already signed up for as well. But yeah, so if you go this month, you can get the early bird pricing for $50. So it's pretty nice. And Sabri just mentioned there in chat that he's got some discount codes as well. So I guess one of the benefits for actually having a CNCF ambassador on the steering committee is we get some of these perks. But yeah, so get it in for this September. It's Oktoberfest also, so make sure you are partaking. Yeah, this month, my beer of choice is from Mother's Brewing Company out of Springfield, Missouri. I got the Oktoberfest Marzen Lager. So it's good stuff. So I'm going to be enjoying this. And with that, I'd like to welcome Ken Sipe. He's, I don't know, you're one of the major or main contributors for the KUDO project. Is that correct?
That's true.
That's nice. Yeah, and I guess I can let you do your own self introductions, but
Sure.
Please have at it. Here, I'll relinquish control of the screen here, and you'll be able to share and all that.
Danger. All right. Oh, perfect. Share That seems right. Let me pull this out of the way. Otherwise, you'll be. All right, can you see a screen?
I see a screen.
How about that? All right, that seems better. Let me go old school with play and window. That'll be great. All right, yeah, so I'll do a quick intro kind of after this slide where I have a slide set up for it. I have slides and code where hopefully that's awesome. That's my preferred presentation style. Also, I'm super interested in feedback. So I've never done this before, not this talk. It's the first time I just threw some things together. It made sense. But I love this topic and what we're doing, and there's actually some old friends among the membership. I would like to be more involved if that makes sense. So first of all, it was about lessons learned, or and someone tweeted, I think it's Bree, that like this was for newbies. It's not entirely. It's really just like the gambit a little bit. So we'll see what we learn. But as I was creating this, I was like, mistakes were made, but not by me. It's actually one of my favorite books, and you'll see like a couple of call outs to certain books along the way. This book is really dynamite. It's a few years old for me. I go through a book or two a month probably, and I happen to have a high fascination for human behavior, and probably even a small segment of that referred to as behavioral economics. So just the behavior and economics combined kind of thing. In this particular book, it's about cognitive dissonance. It's about, the things that we convince ourselves to believe, which probably are not true. One of my favorite stories out of that book actually was a group of people, really defined as a cult, that absolutely believed the end of the world was coming, that aliens were going to fly to a specific house and pick them up at midnight. And the members of this cult sold everything they had, and then of course midnight passed and nothing happened, and it went all the way till 4 a.m. and the leader of this cult came down and she explained that because of their virtue and all these amazing things that they were giving a new lease on life, that they were going to continue, and it's just a funny story. Frankly, they couldn't have any metal on them, and there were people that had belts on, and they had to, at last minute, they were discovered and had to take their belts off. It's a crazy story. But what's even more fascinating about that particular story is those people were more converted after the fact that this challenge did not occur, right? That they weren't picked up by aliens, actually convinced them even further that they were right. So I'm not sure how right you guys feel, but I'm very interested in having an ongoing conversation through the talk. This is me. I'm as mentioned by Paul, I'm a committer in the CNCF on two projects. So technically, it's one project that has two projects in it, if you will. One is KUDO, and out of KUDO came KUTTL. I think I might be the main contributor, like the only contributor on KUTTL now. It was started by Justin, but I took it over. And if you're ever looking for testing, like end-to-end testing in Kubernetes world, definitely check it out. I could use some feedback on it, but that's what we use. A lot of people are starting to use it. It's pretty awesome. I've been writing in lots of different languages. I actually started in C++ world many years ago, but have been writing in Java since maybe 97, 98. And actually I have some timelines in here, but I've been writing almost exclusively Go for the last couple of years. So there's how to get a hold of me, Ken Sipe at Twitter or Ken Sipe at Gmail. Any of those would work. As I mentioned, like kind of experience with Go. Go was announced in 09. They started using it internally. I'm not sure what MOV is. Maybe maybe that's supposed to be May and it was cut off. I think that's what it is. All right. So May 2010, the Google team started using it. It went 1.0 and 12. And just to kind of color, like when did I start? I started using it personally in around 2014 and actually created a workshop at Strange Loop in 2014, which is always September. But it was just personal. It was a personal interest. There's lots of languages for which that's true. Closure, for the most part, is that way for me. It's more personal than anything else. But then in 2018, I started just like 100% writing Go on Kubernetes stuff. And so you'll see my name all over the Kubernetes core and the API machinery code, on Operator SDK, and then of course on KUDO and KUTTL. So, and anyway, that's me. That's some background. So I've retitled like my topics here, kind of last minute yesterday. I was like, first we're going to go the Go way. Well, what's idiomatically Go? What's defined there and what's not, kind of thing. And then we'll look at some navel gazing for linting. Check out the lint. And then we're going to look at some common mistakes in Go. I also have some links. I also have a website, actually. I should make sure that that is exposed now that I think about it. Let's see here. We'll find it. Not a problem, but I'll make sure that you guys get it. It'll come up in some of our demos anyway. So, all right, let's get going. So, mistakes were made. So yeah, I think I explained some of this already, but the key here is instead of admitting our mistakes, we tend to justify them. That's one of the core tenets of like a cognitive dissonance. So hopefully, we can get beyond that. It's always interesting when someone doubles down on something that is, the challenge here is like we still code sometimes in old school ways. Like if you take Java as a simple example, Java was like insanely slow, stupid slow, very early on, and there are still people teaching and developing in a way that would have been advantageous in the 90s, late 90s, which has no advantage today at all, like none. So, and they're very much convinced that that's the way, but they're kind of stuck. We call it, I call it the Iceman paradigm, or the Iceman pattern. They're stuck in the ice age of what used to be. And that's true for Go. We're going to talk about a few of those things as well, I think, along the path. So each language has its challenges. It wasn't until I read this book, Effective Java, that I learned that, Java's just hard. Like it's almost, in some cases, it's actually impossible. What you see here listed on the left is things that are problematic in Java. And if you just take the simple one, the second one, their equals contract, it is actually very, very easy to mess that up. And at first glance, it's like, well, how hard can equals be? But when you have to follow all of the rules for what equals means, like it's got to be reflective and it's got to maintain symmetry and transitive nature, it actually is really, really easy to screw this up. It's super easy. And as soon as you screw up equals and hashes, then all of a sudden, all kinds of things break, like hash maps and like collections of sorts and just all kinds of things. So there's like a lot of things that you almost have to read this book. After becoming a Java developer, you have to read this book and then you have to maintain the content of that book and the language and what is idiomatically Java, and then combine that with a business domain, right? You have to understand all of that and then solve the business problem. So we're gonna take a look at, I wouldn't call it Effective Go because that book's already written, or actually that website's already written. And it's not exactly this, it's good stuff, we'll see.
I know that book.
This book?
No, the
Effective Go. Yeah, yeah. I'm harping a little bit on mistakes. I'll bring up one. As I mentioned, I'll bring up a couple of books, but one book that is certainly worth reading. It's been at least 5 years since I've read this now, but it's one of my favorites. It was written by the CEO of Pixar, but in it he writes that mistakes aren't a necessary evil. They're not evil at all. They're necessary, and without them, we have no originality. And I just think that's brilliant. I think we are conditioned either through school that we do things on our own. We don't copy off others. We are conditioned that failure is an F and that it's bad and you should be shamed. And nothing could be further from the truth. It's just a ridiculous mindset that it sometimes takes time to break free of, and some people never do. So we're going to take that as, hey, there's some great lessons to be learned. And my only hope after this presentation is that if you make mistakes, you're making your own. There's already things that we can learn from, and we ought to use it. So let's talk about what's idiomatically Go. The first is that there are some things that are already defined by the language. It's very opinionated in certain ways. There are no semicolons. Brackets are the way God intended them. There's a certain format to things. It's opinionated in that way, but as opinionated as it is, it's not sufficient, right? It doesn't cover all the ground. So we'll talk a little bit about that. And if I were to look at problems or challenges that I have on the regular working with Go, it comes down to things that just aren't part of the language. Yeah, we could spend time talking about, what can I think? Generics. We could spend time talking about generics. We could spend time talking about error handling. We could spend time talking about a number of things that would be really cool in the language, I suppose. But when I get down to like what I do every day, those aren't the things that frustrate me. The things that are challenging really are, there's too many YAML encoder decoders, and they are slightly different. But more or less, the rest of this, right? Poor naming of packages, Actually, you know what? When we started working on KUDO and started writing Go code in a Kubernetes space, one of our early decisions was the thing we had to answer was, do we want to write idiomatically KUDO or Kubernetes code or idiomatically Go code? And they're so strong. Like Kubernetes, for the most part, is Java people learning Go and writing kind of in a Java style in some cases. And so you kind of have to make that decision. And that's not meant to be a zinger. It's not meant to be a judgment. It's just what is, right? And there are things that you'll find in the Kubernetes space that we would never recommend in the Go community, like util packages or packages that are version packages, V1, V2, V1 Alpha 1, all that stuff, right? It's really, really challenging. And you have to come up with ways to manage all of that. So these are the things, versioning in Go, even after Go modules, it's still lacking. It's still lacking a little bit. Again, not my worst problem, but still a problem. And it just depends on how you do development. So the point of the slide is that most commonly the issues are not the language itself. And so we're going to talk about some of the idiomatic Go way of doing things. So what is that? First, I didn't even know it was going to do that. I don't know how that happened. That's awesome. So one of my favorite things about Go, no questions asked, is that how readable it is. Like all you need to know is another language. And I think that for the most part, Go becomes readable. It'd be interesting to hear different feedback on that. But that's one of my favorite parts. And when I look at, once you get mature enough or old enough, however you want to phrase that, and you've done some coding for a while, you know that you think about code more than you write code. The writing of code isn't the hardest part. It's not how fast you type that matters. And what really matters is longevity. How costly is it to maintain over time? And some of that cost can be reduced by encapsulating correctly. Some of it can be reduced by making it readable. There's a number of things that we can look at when it comes to the readability of code. But I think Go does a really phenomenal job. And there's definitely some edge cases for which that's not true. When dealing with, in particular, notation associated with maybe channels and such, that can be foreign to people. But I don't think it's terribly hard. I don't know, someone else can call me out on that. But so when we're talking about kind of naming things, you can see I have references at the bottom. You're welcome to the slides. Frankly, the PDFs of the slides are in the GitHub repository, which I'm going to point you to shortly. So it's already there. So I'm pointing to a talk that was ancient now at this point, 6 years ago, and I loved it. When we're looking for good names, and this is a very Go thing, right? Like we do things in Go that I don't know if I've ever seen in other languages, like naming a variable I or S or something along those lines. So the rule is we need consistency. It's got to be easy to guess. And if it's not easy to guess, it should be changed. It should be short. And in fact, these rules differ depending on the scope of the reference that we're talking about. And it needs to be accurate. Like it shouldn't be a misunderstanding of this or that, or there's multiple clients and I don't know which client this is kind of thing, which can happen in the Kubernetes space quite commonly. So these are the reference points for what good names are. I'm also going to have some code. It's going to show off some stuff, right? And then the rule of thumb is, what is the distance for which you need to know that reference? That's what matters. So when you're dealing with a variable that never leaves the scope of a method, it's expected in the Go world to just be short, like maybe one letter, as long as it's meaningful. Like you shouldn't get lost with it, right? But That's the point. But the greater the distance, the longer the scope of this variable. In particular, if you have something that's exported from a package. And by the way, I just throw out references or name or words that I just kind of I have to expect a certain baseline of experience, and that may not be everybody present. So if I ever say something that throws you off, like export, just ask. We're here to learn together. So not a big deal at all. But if you're exporting something, that means it's going to be exposed to the greater world, and so that should be a very, very meaningful name, and shouldn't be short because of the nature of it, right? So some quick examples. So this is not winning. For one, buffer is kind of a known thing, and it's only existent for the duration of this method. It's highly likely that we could just reduce that to B. Rune count, of course we're building a rune count, but count is enough, right? Maybe even C, but count is definitely enough. I, J, or K are already well-identified index variables that would be expected, at least in the C language, among others. So we could really clean this up and look at the difference. Like this is one option, this is the other option. And the beauty of it is you don't lose readability, which is the key part, right? That's the key element here, is we don't lose readability. It's very clear still that when I'm taking the length of B, I'm taking the length of an array of bytes. So I'm taking a look at a buffer. If you want to call it a buffer, B clearly means buffer to me. If it doesn't to you, then you might have a little bit more verbosity, but the expectation in the Go world is that you would do something along these lines, that we would intentionally be brief, and in particular, because we only are defining things within the scope of the method itself. If things would live longer, it becomes different, right? And we're going to stick on this topic a little bit. This is just one example. Excuse me. When we look at parameters, again, it comes down to readability. So a D for a duration, maybe that makes sense. That's what we would find in the SDK or in the core libraries. W for writer, very common to see. Some of these you just kind of grow over time to recognize and know. W is writer for almost if used with methods that have anything to do with I/O, it's almost always a writer. Now, if it loses readability, then you may need to modify it. But I'm saying that in the libraries, you should expect things like this. Now, what's different below is like I have two variables. They're both int 64s. Which one's a second? Which one's a nanosecond? I don't know, and I would actually have to dive into code to know. You want to stop people from needing to do that. Someone shouldn't have to read the entire T of a function in order to understand the parameters being passed to it. It should just be obvious. So in this case, we had to name on something, not just S or N, because that doesn't provide enough information in order to be readable. But look at the next one. It's kind of interesting. Has prefix. S is a string, and prefix is some way of defining this array of bytes. So it becomes more readable. What is the prefix? What is not? What is the thing we're looking for a prefix on? Hopefully that's readable. This is, again, part of the core libraries. So, and we go further with that. Again, within Go, we have the ability to return a tuple of values or multiple values at a time. And again, it can be very, very beneficial for the purposes of documentation or just reading to actually give names to these. People will give them names for different purposes, usually one of two. But the one that I care most about is readability. In fact, I just did a pull request review, it was this week, maybe Monday. And that was exactly the advice. They just had a bunch of things being returned back. And I'm like, well, clearly I know what they are because I'm reviewing the code right now. And I just reviewed the method, I understand it. And I know how it's being used. But when you're coming across this code, it's really hard to read and you have to read all the code to get it. You could just save someone some trouble. I know that, if the thing returns an advance, a token, and an error, I have a general idea of how I might use that. And then receivers. Again, the expectation is that you're using one letter or two. That is a convention, so one or two letters, and that it's meaningful in some way. But the other thing that's rarely talked about is that if you create like that last example there where you have a rectangle execute, if you have a handler of a method and you don't actually use the handle, it becomes much more readable to remove the R because now I know it's a handle on a structure, but I know it's also not used within this body of code. I instantly know things I wouldn't know otherwise, right? I'd have to read through the code to understand. So this is an area where people might choose like consistency, like I always say R, star rectangle or R rectangle. And there could be value in differing. It should be about readability. It's not about being consistent necessarily. Clearly be consistent where it makes sense. I'm not refuting that. I'm saying that there are times where readability should trump that. And this is an example. All right, so I'm going to pause for a second and see if there's any thoughts or questions. I'm just going over some really basic, idiomatic Go type things about naming. We tend to be very terse. We're less terse and more verbose as the scope of a thing is elongated, and then the naming of either parameters or return types or the receivers can have value in understanding what's happening within the body of code without reading the code. So any thoughts or questions on that? Anybody want to challenge that? Opinionated of Go as variable names? Yeah, some people like that. Some people don't. Just because I'm with you, Siva. Okay,
oh, and I was
so
just going to mention, if I could,
yeah,
I forgot to mention it the beginning here, but at the bottom of the screen there is a ask a question where you can throw some questions out there, and then even cool stuff. It can be voted up or whatever. So feel free to put questions there.
Sweet. Thank you so much. Okay, exporting. All right, this is, now I'm gonna start getting into things I commonly see, and hopefully to convince you to choose a better path. So you can see here that we have what's that? We have bytes.buffer, we have strings.reader. Notice that it's not bytes.bytebuffer and strings.stringreader. We already have meaning in the packages, and using the package name is extremely useful and extremely important and expected. So for instance, you can see on the right, you might have a method that's defined in the client package, and you would just say client.new. You're not saying client.new client, you're saying client.new. It's in and of itself meaningful. It is enough. It is everything you need to know. Notice though that the package is used, and that becomes very, very important to understand. So we steer clear of things of util and common. Of course, the core violates this. Of course, Kubernetes violates this. Of course, you might run into situations where you don't know where to stuff something. I'm not saying that, but working on KUDO as an example, there were common things that went into util that really had to do with Kubernetes and should probably be under a Kubernetes package of some sort. So this was considered a util because it was a utility to KUDO, but it actually could have been made more meaningful and even more readable, right? What the hell is util? Like that's not a meaningful name. I can't say util.new. What is that? What do I get? Like, so just, I realize that like there's like 3 really hard things in computer science, and one of them is naming variables and naming things. I get that. The other one is off by 1 errors, but so errors. There's a form to errors. If the error type should be of type foo error, the error is the latter part of the type. So something error is the error type. When you have error values, which you don't always create, but when you do, they can be useful for comparison purposes. When you do, it takes the opposite form. It is error foo or error whatever the thing is. So the values and the types differ in this format. And I often see this not correct as well. So Again, not a big deal. You're just getting an error, but using these conventions can help people understand as you're leveraging code and searching for values or types. You know what you're looking for. Some unspoken rules. You don't learn this till you're like well into Go, right? No one tells you these things. Well, I'm going to tell you something. The happy path should be dedented to the left. And that's how you know what the happy path is. Everything to the right is some kind of exception case. It's some kind of break, some kind of, exception case or error case, error handling, something like that. And there's value in refactoring until this is true. It is also possible that it's hard to reflect that within a body of code, within a method. And then oftentimes you just need to refactor it so that there's two methods and you can maintain this order in two different methods potentially. So this shouldn't be hard, but it's one of the things. Let me show you an example. So a couple of things. First of all, we never do this top thing where you say things, if X is greater than 2, return something else, return something else. We always return a certain case, like if it's greater than 2, return 100. Anything after that is else. You don't need it. So notice that the happy path tries to stay as far left as possible. The happy path, in this case, it's not exactly a happy path, but the code path stays as far left as possible. And we're going to see a happy path here shortly. So this is just one example. This becomes, I think, a better example. Notice the chaos that happens on the left. In the left, I mean, this is the exact same code, right? But I have if else and returns of errors, and the else is inside another if block, and there's another last else, and it's just hard to process. It's less readable. That's the best way of putting it. It's obviously understandable. Anybody with general computer science understanding could walk through the paths, but compare that to the right. To the right, we check to see if there's an error. If there is, then we return it, and we're done. We return errors early and quickly. That's intentional. What happens is when we continue past that error check, we're on the happy path, so everything stays left. So I have another process, and I check for errors there, and then I return the error, and I'm still continuing on the happy path. Everything to the left is happy path. Everything to the right is error handling or exception cases, right? So we begin to see, now there's no hard and fast rule here. There's not even a linter to check or verify this. This is just good engineering discipline, right? And of course, because of that, you're gonna have people with different opinions and different histories, and someone coming writing, Go code that was in the Java world where they have written a bunch of Spring stuff that has, words that are 120, it looks German, right? It's 120 characters for a variable name. So I work with Germans all day long, and I'm half German. So that's not a racist comment. That's being fun. I love them. Besides, we're celebrating Oktoberfest. Come on.
Exactly. Prost.
Exactly. Okay, so project setup. I'm not going to spend too much time here unless someone asks me to, but there is a standard out there. You can see it down here at the bottom for project layouts. I do see people vary on this, unfortunately. It's one of my first pain points. I look for two things when I first join a new Go project. And one is, do they follow the project setup in a way that I would expect? And if they don't, it's one of the first things I submit a pull request on or engage on Slack into questioning. The only slight exception here is if you see on the left here, you see the root, and then you see a command. I do expect my commands to be there, command line type things. If it's not, it's very common that it's in the root, and I'm okay with that because it's historically, that's what it was, and it's not really a big deal. It's very common when you have a CLI or a command program for which you only have one of them, that might have it on the root, and I'm fine with that. The thing that is a little bit odd, especially if you're coming from other languages, like Java as a great example, I only reference that because I expect that there's a lot of people familiar with that language. But in the Java world, you would expect the source tree to be inside of your Java project. So you have a project in GitHub or wherever, and inside of it, you have an SRC source tree, and you might have some breakout from there of Java or main or tests or whatever. But the point is that within that language, like many languages, The source is in the project. And I like to think of Go projects as the Go project it belongs in the source. So it doesn't define a source. Everything in it is somewhat potentially source code, but the source tree, you will land in the source tree, right? So the source is outside of you, meaning the location where this project will land. So so it's very different in that way. And you can see here I call out go path slant source is already defined somewhere. That would be my expectation again. Now, some people, especially with Go modules, have vary a little bit on this. I don't like to. This is one of the areas where I do like Go modules and I use them, especially for submodules and for other things. I definitely don't use vendor the old school way of dep and all kinds of things. I like Go modules, but I don't deviate from this. I have a Go path that is, for the most part, my machine has one. I don't vary it for lots of different projects because that's just craziness. And I have a source tree for which all things are under, including whatever my repo name is and whatever my project name is. So an example is if I was I've been submitting some pull requests on some linting on Kind. I don't know if you're familiar with Kubernetes and Docker, but Kind. For my platform, I have a Go path source sigs.kates.io /kind. That's where my project lives. What's also really great about that is whatever dependencies are needed for that, if I already have checked out things, it'll potentially pull from those locations on my local machine as well. They're all considered part of the source tree, if you will. So this can be good. The one thing that is, I don't know if I have much more to share on this other than internal is a location for which you are never exposing anything outside this project. And I'm seeing people starting to use this. I definitely see some projects that have it, but we probably ought to use it more. So I'll leave it at that. You have to decide what you truly want to export and what you don't, and whatever you have internal is never exported outside of this project. So if you're not familiar, there's probably some good lits on that, or ask. I don't know if I like this one, this thing called hack, although almost all my projects have it. It's such a weird name. It's where it's a dumping ground of just stuff, right? It's where scripts are, and if you're doing any kind of Go building, like a generator, if you're doing code generations, a lot of times they're underneath the hack, and it's just it's a lot of your tools are there. It's just weird. But it's far enough that we're kind of stuck with it, I think. All right, organizing your imports. So there is a defined way of defining imports, but I go a little bit further. Almost all the projects I work on work this way as well. What you see here are 3 different groups, and the first group is everything core. The second group is pretty much any dependencies I might have, and the third group are things that I'm using out of my project. And my formatters, when I literally just hit, if I'm in Golang, I hit Command-Shift-L, it auto formats. My formats automatically match my linters, which is great, but it also automatically forces the imports just like what you see here. So I do almost no work to do this. My only problem that I have is when I'm working with others who don't use, Golang, and they have to manually do this, or they don't have the right tooling to do it through some kind of scripting. And then I have to reject their PRs. It is useful. It does share some information, but I really love having my dependencies separated out. And I can see, what third-party things we're using. And then I can see also how much contention, or you might call it like a big ball of mud, how big the big ball of mud is growing based on the length of the imports here. If you're importing it, yeah.
Oh, sorry, I'm interjecting here, I guess because I have the microphone and I can. No, I was going to ask, I have the power. But no, with this Go funct, does it actually organize the imports, or you had to do the separate Go import, don't you?
I imported, I'm sorry, that is an import that I'm using. It's also a great library. GoFunc is a great way of doing like functional style, like maps and zips and things like that in the Go world. So that's what it does, but that isn't what formatted this was me or my editor.
Yeah, sorry, I meant to go funked. The FMT,
This here?
the format, not go funk. Not
Oh, I'm sorry.
yeah. Go format or go funked. I've heard it referred to as funked.
Yeah, there is a formatter. We'll have to look at my editor and see. There is a formatter I had to choose and I had to configure in order to get it to do this. So I'll definitely show that off. Remind me when we get to the editor. In fact, let's go. All right. So as I mentioned, I have references here. This is where the code will be. The whole abstract here, the different branches we have, references to code, all of that's there. I'm going to pull this away for a second so that I can, hopefully you guys can follow along. Where did I? Oh, there it is. Okay, sorry. Okay, so step one, can you guys read this? If I do an LS here, is that big enough? Do I need to grow it?
Yeah, there we go. Good? That works for my old eyes.
Something reasonable. Okay, so first, I think we want to start. This is just project setup. I don't know if we really need that yet. Hold on a second. Where am I? Oh, let's just start with 2. Okay, so I'm actually using 2 editors. One is VS Code. I actually love both of these. I know there was a vote last week or last meeting. I don't know if I could work without both of them for different reasons, actually. So I think refactoring and project management and adding dependencies are so much better in Golang, but working with the files and versioning. And I also have some really cool things that you'll see here in a second that I can do from my command line that work with VS Code. So step 1, here's our project. Let me make sure I understand what we're going to do here. Okay, so the string array. I don't know if we talked about this yet, but it's worth looking at. What I have is I started pulling out some Go. I have a Go lab, which you'll see out there as well on GitHub. And I started kind of teasing it apart, showing off some of the things we're talking about here. Text bigger. Yep. So for this example, it's nothing more than executing this code that does a reverse. If we did it, let's say go run that. So I'm just reversing Ken as a return. You can see that I have a string reverse here. You can see the code here for string reverse, literally just doing reverse. And then of course, we wanted to create a string test. So we have this test. So we already saw it working. It works fine, right? So let's go ahead and run this and see what we get. And we have a failure. And this is also one of those pain points that we run into on Go as well. You have to know kind of, well, it sounds weird. You have to know what you're doing. You have to know like the context of things. And in this particular execution, if we were to dive into reverse again, and here's the code, the problem is that we've got a byte array buffer, and with strings, it's not appropriate. We would fix that by making this a rune. And then all of a sudden we hit the run and everything's good. So it's very easy to run into a problem like this, and it works great. And then one of my early issues when doing database development in the late 90s, I call it the O'Brien issue, where I had an O'Brien with an O apostrophe, and it broke stuff because I didn't code well. That's this, right? This is the same problem. You can get it to work for most names, and then it breaks because they have a Unicode character. They put in a something. So step 1 is just using a quick, example of running into an issue with reverse. We did that just on a simple test. We have test passing now. I also have this broken up into a project layout that I would expect, as mentioned. I have a command, CMD. That's where my main is. So W man is intended to be weatherman. I guess we could talk about whether that's appropriate or not, but that's what it is. Frankly, this is not weather at this point anyway. So returning, getting some output out. I have a package with some strings. Well, we run into an interesting question here. Should this be string reverse? Well, that makes sense at this point. I also have some linting going on, which we'll jump to in a second as well. Any questions about that? We're looking at the test, looking at project setup. pretty simple stuff at this point.
Yeah, and actually there were some questions that queued up from already earlier. I don't know if you want to address them now or at the end.
Let's do it.
All right. So Sipe was asking when to use receiver methods when using them. Are there any rules or conventions?
I don't know if there's. So let me reflect on that for a second. First is the alternative would be to. Well, it depends, right? So one option is I've got the structure and I want to perform some behavior on it in some way. That, of course, is going to have a receiver method. Where you get into potential questions is, do I pass that structure to a function? That's one option. Do I pass, when I'm inside of a receiver function and I need to call another function that might be reused across other things, do I call that as a receiver function or do I call that as another function? All of that is possible, right? The things that I would say, first of all, there's not a hard and fast rule that I'm aware of unless someone wants to volunteer something. But what I would think about are these things. Anytime that I want to change the internal state of a structure, then I'm probably going to use a receiver method for that. I have, and in particular, something that I'm not exposing, I've not exported. So if I have something that has internal state, it's not exported, there's no way to get it, then it has to be a receiver function, right? It has to. So then it becomes readability. How do I want this to be viewed? How do I want it to be seen and understood? Do I want to require the construction of an object or a structure in order to have this thing? Some simple cases. Again, it comes into readability, right? If I were to create, like there's some good examples out there. If I were in the Kubernetes space, to connect to Kubernetes, I need to have a client. I would go to a package. I would I would invoke a function. It would return an object, essentially a structure that was predefined, which is awesome. It's totally encapsulated behind the package. Now, what are the things I want to do with that client? Well, those are the receiver functions, right? I obviously want to get something. I obviously may want to delete something. I may want to post something. I may want to put something. Those are the kinds of things, and it's whatever the verbs are for the activities I want to have on that noun. Beyond that, I mean, it becomes a little bit subjective, and I would have to know the case. So I think if you're looking for like a solid, it's always this. Well, first of all, I don't believe in that. The perfect consulting answer is it depends.
Well said. Yeah. And here was another one. This is, I guess, more of a comment from Sipe. He's really going for the giveaways, which I don't think we have any for this actual session, unfortunately.
Well, I'll have to come up with something.
Yeah, exactly. But he just mentioned that he liked the statement about governing the length of a variable name, that the greater distance from the usage, I guess, the longer the name should be. Yeah,
that's true as well for a dynamic language, right? Not that Go is, but people like to complain about needing to know so much context with the dynamic language. Well, that's just you designed it poorly. But when you're working with something that has a very tight scope, you can be more terse, and it just seems obvious. But.
Yeah. No, and then here was another one from that, and this was more on.
Yeah, Sipe, that's a great question.
Yeah.
I'm seeing the question too. It's about complexity and Go. That's actually one of my first complaints about Go was the number of returns, which obviously increases the cyclomatic complexity. And I mean, you have to pay attention to that. And usually what it means is breaking down into more functions. And it depends, right? First of all, a good point. Second of all, add a linter for that, which we're going to talk about. So, in fact, why don't we come back to this, and I'll dive into linting, and it looks like there's more. Just we'll make sure to share all these things and then get some more answers. All right, linting. What the heck is this thing? Well, there's some things that I always have on all my projects. Doesn't matter the language. It doesn't matter the language. If it's Python, it's Pepe. If it's Java, there's other linters. If it's Go, There's a couple of them out there. We're going to talk about a few, but what they do is they analyze code. That's their job is to make. Here's the thing: if you read like Effective Java, there are so many things to know that it's really hard to maintain consistency. It's really hard to maintain the knowledge of that while you're trying to solve the problem at the same time. So we need as much help as we can get. And that help comes from running or creating unit tests, but the help can also come from creating or applying proper linters. So the kind of linting that we have, you can see it listed over there. I don't know if I'll read all of them, but it comes down to, do you have unused code? Do you have cyclomatic complexity? Is it too high? What is your number? What number is okay for you, right? Like that. Those are what's your line length limits? And by the way, I'm in the camp with Linus Torvald, which is I have monitors that are very modern in 2020, and I am not sticking to 80 characters ever, unless forced to by Python, and I hate it. So just forget about that. Now, with that said, if you have something that's 250 characters, well, you know, at that point, it's not that I can't see it on my monitor. It's a problem with trying to review the code on GitHub, and I don't like scrolling too far left or right. So, because I start to lose context. So it's just humans at this point. But anyways, that's a linter. We could have a linter that looks for line length or stylus type stuff. There's a couple of really good ones out there. You can see a link down here to awesome Go linters. So there's a number out there. We're going to pull out a few of them here. Some that I almost always use are like static check. This would be, it's like Go vet, but on steroids. And it's awesome. We're going to see some examples. So hold on for that. The complexity numbers we talked about, so adding that in is something I definitely love. You'll see that there's a lot of orgs that might use linters, but they pull out some, and I think it's I don't know. You have to agree as a team what you want. I'm okay with pulling out line length limits, but I can't pull out my complexity numbers. I have to, define what it is, and let's go with a higher number if that's what you really want. The unparam is, do you have any unused parameters? Error checks, do you go through code and just put underbars for all of your return or for all of your errors? Well, this will identify them and then shame you, right? And then your solution for it is you can configure a ignore in the config file, or what I prefer is to actually have a comment at the line of code that says ignore this lint for this reason. So I like to put a reason for why a specific thing was ignored when it's appropriate. I also sometimes turn off certain linters. Error check might be one of them for tests. I don't care if you're ignoring errors in tests and sometimes I do. It varies, but I've been on enough projects where we do ignore it in tests, and I'm okay with that. I'm less okay on production code. So there is one linter to rule them all, and in your code base bind them. And that is golangci-lint. Just install it, man. Brew install this thing, or do the go get on it. This is the thing that will, it's like a meta linter. It pulls all those other linters together. And I don't know why anybody would not. There's two things in a Go project that I would use for on every Go project if I control it. One is this linter. The other one is Go Releaser. Go Releaser is phenomenal for releasing Go code for lots of reasons. It has a couple of issues. I still would like to have multiple architectures for my Docker implementations, which it doesn't fully support yet. I have to manage outside, but that's a different issue. Let's talk linters. So if I have a config file, it might look like this. So in my project, I'll have a .golangci.yaml. You might disable all of them and then enable them one by one. You can configure your runs. You can configure that the timeout should be a certain amount of time, so 3 minutes. You can also see a lot more linking here than I gave you, and there's many more than this. So this is just in fact, I truncated it so it fit reasonably on a slide. You can see the URL on the right, which is where you can get more details on configurations of this linter. So install it, then have this config. When I worked on kind and they didn't have it in the config file, which I think is ridiculous, I put it in the config file, but they didn't want it in root. It is totally possible to put it anywhere else in the project. and then specify a dash config and specify where the file is located, and everything works fine. So this is linting. So let's actually switch to, let's see here, git checkout 3, lint 1. What is your problem? Oh, I changed code. Doop. All right, so make lint. And we have some issues. All right, so let's go look at code. Oh, this is one of those things I was telling you, like in my editor here, if I hit command and I highlight over, I can just jump right to code and VS Code. So I don't know why I wouldn't do that. so within here, what we're seeing is a couple of things that might feel a little bit weird, right? So it says file, not go imported. And then it's giving you maybe an instruction on how to fix that yourself. This is from the linter that's go imports. Now this one is a little funky. Like I know it because I see it all the time. It doesn't really give me a good feel of what's wrong, but it does tell me a line number, 41. It does have this right here. What's on line 41? It is that character right there. What this is complaining about is it expects an end line. So you can see that I put a carriage return. I have a blank line at the bottom. And if I said make lint again, it comes back with the other file I didn't fix yet. So it's telling me here I have a standard, and the standard is there's always a blank line at the end of a file. And if it doesn't exist, then shame on you. Go fix it. Now, of course, if you have this in your CI builds, which all of my projects do, linting will happen and you'll have an error, which won't allow a merge if we don't follow the rules. So now we have fixed that particular lint problem just by adding those. So that is the first linter. Let's do a checkout on, oh, this is the one thing I didn't expect to do, but my gun do is just like reset to like, don't take the current code that I just changed. I'm changing things on the fly here, but let's do a checkout on EX4 and do a make lint. And now we have some of the things, remember on the slide, we said we had dead code. Dead code was saying, hey, I've got this new lint command, and it says, hey, I've got this check which isn't used. Let's go look at code for a second, see what we got. So in this lint, I have this new lint command, and I'm not using it. So one would say, hey, I should probably delete this. Again, I could say over here, no lint, dead code. Now, if I do a make lint, you'll see that that's missing. So we're no longer checking, well, it's hard to see with that much stuff online, but you can see I have only one dead code now. I don't have two. So that's one way of fixing it. Not really awesome, but possible. If I were to do that, I would hit a space. I would hit another comment. This is required, by the way. And then I would put some reason for this. That will be, the comment will be ignored by the linter, and what it knows to not lint is the dead code. So now I can put reasons with my linting. In this particular case, the solution is I created this new command and I have this root and I just didn't use it. So what I want is something along these lines where I'm like, oh, I meant to put that in my root. Let me put that in here, hit save. Now I'm actually using it. So now I fixed the one. The second problem that it had was this guy. Let's jump to that. And we have check. Now, who knows? What it's saying is this is unimported, right? It's a lowercase c, so it's not exposed beyond this package, and nowhere else in this code is it used. So it might be an error. We should delete it. But you can also export it, and now because it's exported, it can't know whether it's used or not because it's a library, right? So we've just now fixed the first two lints, and we're on to error checks, all right? So let me switch the slide real quick, and you'll see, hey, I've got these two lint errors. Use them or delete them. And in the case of check, we meant to export that, and so we did by making an uppercase C. So in this case, it helps to keep me honest. You have this code and it's not used. Do you want to maintain it? Yes, I want to maintain it for whatever reason. No, I meant to export that. Oh, so it caught something that potentially I meant but failed on, right? So that's the point of linting. We've done that. Okay, error checks. So a couple of things here. First is it might be useful to go to my linting configuration. This is what I'm using. But what's important here is I have a timeout of 3 minutes. If it takes longer than 3 minutes, it'll time out. but I go somewhat aggressive on my error checks. So this error check is going to check type assertions equal true and check blank equal true. So that is a level above normal. These, by default, these are false. This would be the same. This, if I could either delete them or change this value to false. It says if I deleted them, right? The default is that they're false. So I'm going to change that both to true. You can see here, because of this, I'm doing a conversion of A to I. So I'm converting something to an integer, and I've ignored the error. So because of that, going back to the command line, let me clear the screen again and lint. This right here, if we were to jump to it, it would say, hey, this is not allowed according to our standard. This is not shippable code. You have to actually catch this error and do something with it. And now it's fixed. So if we were to go back and hit lint again, it's gone. If you see me flash on the screen, it's just too much text. I want to keep it clean. All right, remember that rule I said? Let's keep everything dedented, keep happy paths to the left, which basically means never use else. There's exceptions. There's always exceptions, right? But here we have a lint, and what we're saying here is a couple of things. Here's our check code again. We have an if test, return true, else return false. Well, this is ridiculous, right? There's just no reason for that whatsoever. You could just do this, and this is accurate. So this is the same code, but better. We could also, it's also valuable to realize that this check is a little bit weird, but what we could do instead is just return test. So if this were instead maybe a string, and you were doing like you're just checking to see if it's a zero-length string or something, right? You could say if test equal this, return true, and then return false, right? But what we would prefer to do, again, whoops, in Go code, is if that is what you really want, you would rather do something along these lines: return test equal this. This would be the preferred Go way of doing what I just explained, right? Like you would just return the already evaluated case if you can. But you certainly would not have an else. There's nothing that makes sense about that else case at all. So this will pass the linting for the changes that we made. What else we have? Here we have a lint. And this gets into some oddities with Go, right? Like range is just an odd thing. But it's only odd because the range has some slightly different behavior depending on what's on the right. That's the only weird thing about range. So in other words, if we had a map on the right, then we would get out of the range a key value. If you have an array on the right, then you're going to get an index. So in this particular case, you're ignoring this value out of the set. And if you're ignoring the value, well, then you just don't need to express it. You just don't need to express it. This is executionally the same code. So, and this is also another weird thing about range. It's one of the things you can call for which there's a tuple that's returned, and you can decide whether you want to capture all of the tuple or not. So again, an oddity from a code design standpoint. And by the way, I'm going through this. You guys should keep me honest if I'm missing something. This is to simplify things. So let's go here. Now we're getting into Go Simple, and there's a lot of things in Go Simple I like. Let's jump here. What's the problem? First of all, let's see here. Omitted. So it's this one might have to look at our solutions. I don't think it's that, but no. This should be more obvious, right? Here's the thing. This is proper. You see what strings are? Strings are defined up here. It's an array of strings, right? So, and it's just an array of strings. What we're doing is looping through the array, getting strings. And what we would prefer in Go is to get rid of loops completely if we can. But we want strings, but what we want is strings ... It might actually be the other way. So what you're wanting is break out the strings for me. And it just so happens, if you know enough about appends, the appends is it's a variable argument, so it can take as many arguments as possible. So what we're doing is saying, well, expand this array into those variable of arguments and pass that as parameters, as opposed to looping through passing one at a time. So that is a common thing to see. So, and it actually told me right there, and I did it backwards, of course. In the Navy, I was in the Navy, if anybody doesn't know, and we had a phrase in the Navy, and it was like 50, 50, 90. And what it means is that if you have a 50, 50 chance, 90% of the time you'll get it wrong, which usually is true for me, actually. So, I was in nuclear power, so there's no room to be wrong in that field. I was a nuclear reactor operator. So, this one's fun. Again, there's really nothing wrong with this regex. Let's look at this regex expression. It's right up here, right? I'm looking through matching on a regex. There's really nothing wrong with it. That is it's failing the lint though. So what might we do? Well, the preferred way is to use the backticks. And if you use backticks, it basically says take the string exactly how it is. So there's no need to escape anything if it's exactly the way it is. So the preferred way of doing regex in Go is to use the backticks, or I think it's haradox, but it's basically a way of defining the string exactly the way it is. And again, that's all you would need to pass that. Again, I don't know, like the readout on these linters, I think is pretty good, but I've seen a lot of them before. And then obviously I created these, so I know them. But the other thing I would recommend is you can just do a search on this S1007 for linting on Go, and you'll come across, examples. Here's how to fix it, things of that nature. Here's another interesting one. It turns out in Go that if you have two structures, so I have a structure for T. Where is T defined? So here I have T1, I have T and T2 defined. Notice the structures of them. They're exactly the same structure. So they're different structures. I have something of type T, and I have something of type T2. But the structure internal to those structures are identical. So one way of taking a type T and converting it to T2 is to do this. But that is not the preferred Go way of doing it. If you know that two structures are the same, the preferred way is this. And that is exactly what the complaint of the linter was. The linter said, hey, these two things are the same thing. All you need to do is almost cast, if you will, X to a type of T2. And now Y is an instance of type T2 with the same structure, the same values of the structure. Is that okay with everybody? That we're starting to get on more of the more advanced side of things, and obviously it takes a lot of knowing Go to get through a lot of these details. All right, so back on slides, let's see, we've gone through that. Again, these slides are great because you'll have them, and I didn't even get to this one. I don't know why I didn't see it, but when it's probably on a different branch or something, but one of the Go imports is like, look at this, it sees that this is out of alignment, and once you hit format, it will format to this, but this will fail on a Go import. So this is a great to get proper alignment before you actually commit code. We did the air check, Go lint. We talked about this one, which is great. I think this even talks through the example of switching to a return of the type. The Go lint on keys when you don't need the values, more details on the structures. The slides will be great when you don't have me anymore and you're trying to remember something. Or give the presentation yourself, I suppose. I don't know. This one is Go simple. It's basically saying, hey, you don't need to check for nils if you're checking lengths, because lengths on a nil is fine. So this is extra. You don't need it. It just makes, verbosity makes things less readable. So when we're focused on readability, this is perfectly readable. We understand what it is. This was the example of the regex. This was the example of not looping, but expanding variables. And we've done this. So, okay, so that was linting. I hope I've convinced you to lint. All of your projects should have navels involved. Start collecting.
Hey, and Steve had a question there in the chat. He was
Yeah.
mentioning just what would you consider the difference between doing Go format versus a linter?
Yeah. So there is some overlap, and there's definitely some tools already out there like GoVet, GoFimp, Go. There's a number of them out there. Some of them actually change code, and some of them actually just report on code. I don't know if that distinction is global or ubiquitous. I don't know. I personally see linters as not something that changes my code. It's something that reports
Right.
on code that needs to be changed. So that said, some of the linters, if you put in the right flag, might change things. But I would rather, I don't know. Depends on what you're after, right? Like I have learned so much about the language and about how the language can be better by being shamed by my linter, right? Like it tells me, it blocks me. And sometimes I yell at it. I'm like angry, right? Because someone really, really smart made me feel dumb. But I actually prefer that. I feel like I'm smarter about the language itself. And I would rather not have it automated. Now, the things I do like automated, I absolutely love the imports to be automated. I just could care less about the imports, but I'm very particular about what they look like. And as I mentioned, for me, if I'm in Golang, if I hit Command-Shift-L, it does it. It does exactly what I want. Oh, we should have looked at that. I don't know if we'll find it. We're going to run out of time, and I didn't. Let's see here. What am I looking for? Import. Yeah, I'll have to hunt for it later. I'm not sure. It's in here somewhere, and I'm missing it, but this isn't it. It's probably under here, actually. Yeah, I'll have to hunt, but in there will be some details about it. They make that harder to find than it should be. All right. So coming up, how long do we have? I don't want to go too late.
Well, we've got 2 hours altogether, so we've still got time. And
Okay,
just
great.
in case if we run, I know how to handle it this time, I think.
Oh, good. Well, I don't think I'll go too long. There is something like when I initially came out with this talk, there was something that I had in my mind that we are about to get to, and I just want to make sure that we get to it. So, but when I decided that, when I create a full presentation, adding in linters just made sense. So, all right, why don't we jump into it and make sure we capture it. So first, I just ran across some code that did something interesting, right? And that thing that was interesting is it created a channel of strings with the length of required images. So it probably gives it away that it's in kind somewhere. There's a link to it. So it begs the question, why would I create a channel of strings versus an array of strings? And what's the difference? Now, when I thought about this, why did someone do this? Now, the first thing you should know about me is if I ever say that that code looks clever, you can be assured that I don't mean something kind. Developers tend to like to try to be clever, and I do think it's cool. I do like competitions where we're trying to create the most clever thing possible. Of the people that I think are like super attracted to shiny clever, it's the Scala people. They just love clever. So I'm gonna start a war on this channel, I think.
That sweet one-liner of code.
Oh, it's so beautiful. Yes. And one person, and what you had to know is like somewhere deep down into the project, there was some implicit that you missed, and you just had to know. Or the magic of an import changes everything from be immutable to not, and just craziness. So when I saw this, I was like, well, why? Okay. Right, Brandon. When I came across this, like, why would I do that? So the first thing is, if I have a string, if I have a channel of strings, if I wanted to range over them, which is what this code does, maybe we can jump to it. You know, what the code does is, well, that's pretty small. There we go. You know, we create a, you know, we're going through, we're ranging through images, but then we're actually adding things. And notice what you have to do. On a channel, you can't range over a channel until you've closed it. So I don't know where in here that, there it is. There's the closed pulled images. So we can't actually do anything like range over the pulled images until we do this. That's a requirement in language. So that's another thing to know about the language is those kind of details. My preference is to probably just use an array of strings. I don't know why they didn't. It begged, you know, when I was looking at code, I was like, okay, when would I do this? Like, is there a time? Yeah, there is. If I had a bunch of Go routines that were all adding strings to this channel, so I have a bunch of threads adding strings to this channel, that eventually, after I joined on whatever this work group was, that then I wanted to close it and then iterate over it. That would make sense. So I really do think that this code here, and again, I think there are some super, super smart people on this project. And the things you have to know about this project are insane. You got to really know Docker extremely well. You have to know C groups like really, really well. Like you have to understand the mapping of C groups inside of containers. There's so much stuff you have to know. It's really, really challenging. But this is added complexity that I would have fought. And it turns out, by the way, that the reason I even came across this code is if you look all the way up, look how long this function is. You come all the way up, this function right here, the default cyclomatic complexity is violated on this project, on this method. So that's how it grabbed my attention. And clearly it's a mistake. And we all make them. It's not a big deal. I think it could be improved by not doing, unless they're going to go out and create a bunch of threads, which they're not. So anyway, so, you know, the point here is this communicates something. If as a Go developer, when I run across this, I'm instantly prepared for concurrency. I'm instantly prepared for Go routines that are going to be kicked off somewhere, and not seeing them confuses me. It makes it less readable because now I'm left with questions. Why? What, were they planning something and didn't do it? Are they planning to still do it? Could we change this? Should we make it less complex? Because this complexity doesn't add any value whatsoever. It is somebody who decided to make channels because they, and what it, you know, potentially it looks like the new shiny thing, right? The new shiny thing is Go has channels, so we should use them. Well, probably maybe not. You know, when appropriate, yes.
Channels for all the things.
Channel all the things. I'm channeling now. Exactly. All right, so enough on that. That might be a little bit of a rant, but again, my focus on this was to talk about readability, which you know, it's challenging when the language is so great at being readable and people make it less readable, right? And that's really what we're talking about. And so hopefully that's the takeaway. And I'll reiterate, I love this project. I think they're insanely smart people. So there's that, right? Really, really smart. But this wasn't the big problem they were trying to solve. If someone was, they probably would change it. Would be my guess. All right, this one's fun. Build tags. Let's go over here. I don't know. Check out X. Is it? No. X. Build tag 6. Okay, so I'm gonna check out build. Yeah, Sipe. Stop it. All right, so we're on build tags. Now, what's important about that is this. We're gonna go over here. We brought in this project. We have weather. We have types. I don't remember where it is. Lint test. All right, well, let's just look for it. Lint test. Okay, so here's what's interesting about this. Look at, this is doing a test. Let me blow that up for you. And notice that it has a build integration. Notice that I could say go run. And I don't know what that's doing, but notice we can run the project, right? I can even run the project and run the lint subcommand. So I've done something. I don't know what that is yet, right? It's just an example. So, but now let's go, in fact, let's make test, and our tests are good. Great. Now let's say make integration tests. And we look and we say, oh, we have a failure. What is this failure? It's a build failed. Why did we build fail? And what's important here is that it's possible to have Go code that doesn't compile in your current environment. And if we were to even dive into this function, notice it can't find it because it doesn't exist. This exists. So I have an uppercase C, and that would take me to the check that we had before. But how is it possible that I have code that I didn't catch as a compiler error? And it has everything to do with this build tag. Okay, so the build tag, what is it? First of all, let's look at our makefile and notice that our integration test says go test tags integration. So whenever I say go build, go run, if I said go build or go run with dash tags integration, it will include all build tags that match that tag as part of the build. So I could have caught it in that build. I'm also saying that I want these to be run in the tests and those tests only. But notice how the editor and my command line doesn't fail a compilation failure by default. Now I can go into my environment and say that, I forget where it's at. If you edit your configurations for builds, you can actually change somewhere in here just trust me, there is a configuration for it. I'd have to hunt for it. But there's a configuration to say include in this environment, like integration. I don't think it's environment though. I use it all the time, so I'll have to hunt for it. But the point is, yeah, well, here, I'll go to my KUDO. Hello. Yeah, it's compiling. Let's take a break. All right, things are locked up on me. Back to presenting. Here's the main point. The main point is make sure you understand the build tags are involved with your projects. There are a number of projects that use build tags. I tend to use build tags for integration builds, which is a way of saying that when I run tests, they run tests that are not integration tests. And when I run tests with integration tests, they run integration tests. So there's a couple ways of managing that, but build tags work out really well. There's other purposes for build tags, but that's the big one for me. All right, are you working now finally? Yeah, let's go up here. Yeah. Oh, go build. Let's look under build. I might have been looking at the wrong place. Yeah, I'll have to hunt for it. I don't remember. This entire project will always compile everything in the project, including integration tags. So I know that particular project set it correctly, but I wasn't prepared to actually show it apparently. Just wanted to bring awareness. Okay, so we did that. Okay, the cool stuff, the hard stuff, the stuff that happens more often than it should, and the part that is bewildering. So changing values in a range. So here we have a slice of ints, right? Everybody cool with the terms? We have a slice of ints, which is an S. I'm going to range over the slice of ints. Since it's an array, we'll get an index and a value, presumably, right? And then I'm going to say n plus equals 1. So n will be equal to n plus 1. And then when we print everything out, we get 1, 1, 1. That is not exactly what we were looking for. So we could come over here and instead get the index. Notice how we got rid of the second argument. We just want the first, the index. So now I'm getting the index and I'm accessing through the index, the slice, and adding values in there, and I get the right output. Now, the thing that really throws people off, it happens, it's probably the source of a lot of bugs, is that when we're ranging through something, I'm going through a for loop, ranging through something, the value here is a pointer. And the pointer that we're using is the same pointer over and over again, pointing at different values. So here, let's look at another example. So this is true. Just be aware that one solution is to actually use the index of the location, and then we're changing the value of the thing we're looking for. Another example might be this, and it actually shows another solution. So here we have, we're looping through the output, and notice that I'm looping through my outs. I have an array of pointers of ints, and I have I, and I'm incrementing the I, and then I append out to whatever the value is. So I'm taking numbers, right? I'm supposedly taking numbers and then appending it to the array, and I'm using the dereference of I, so the value of I, I'm taking the address of it, and I'm appending it to this array of out. And if I were to output this, I will see 333, and my expected values were 0, 1, 2. Does everybody follow along with what's going on there? The address that we're pulling out is the same address in this for loop over and over again. And we keep appending the same address. And when the address is done, in other words, it's been incremented the max number of times, the value left in that pointer is pointing to the value of 3, which is the increment past the max value. And that's what we get as an output. But this seems totally foreign to people. This confuses people. Again, source of many bugs. So what is a way of solving this problem? Let me see if I actually have this. I think I do. Okay, check out 7 loops. Let's go see what we have for loops here. I think it's another main. Okay, so just because I have to be known as right, I want to see that the output here is 333, and notice that the addresses are the same as well. So we appended 3 separate times in a for loop where we are incrementing a value, and yet we got something surprising. So probably the most common solution here is to say I equals I. So, and then if we make this change, and I say enter here, oh, sorry, let me do one more thing. My bad. We're creating a new I, which is equal to I, and I hit enter on my run, and notice that I get a 0, 1, 2. And I get different addresses, which is also what I expected initially, right? So this is insanely common to need to do. And even the more seasoned Go developer will run across this and fail, right? You just have to be aware that this is the thing. When you're in loops, when you are looking at addresses, when you are looking at interfaces, when you are looking at structures, in particular pointers to structures, you have a potential problem, and that potential problem is remedied by creating another instance of a shadow variable equal to the value. So you're basically doing a value copy right here to a shadowed variable, which then is being referenced here or dereferenced here. So I'm going to pause for a second. If there was one thing that I wanted to talk about during tonight, this was the one thing. It is, if you look, do I still have it open? I don't. I'll load it up while we have questions coming through. But if you look at any of our tests for KUDO, and I probably could just be so lucky to just say star test, maybe star underbar test. I'll just go to any one of them. And you'll see I have a bunch of tests, and this one failed me. That is very rare. I'll have to look at that. But if you look at most of our tests, you're going to see, here, let me do a search for TT. So you're going to see this all over the place, where our TTs is basically equal to the range of tests, which is this essentially this big array of tests. And TT equal TT is to make a reference copy so that we're not doing the wrong thing. It's the only way to pass in the true value of name during this iteration. So the whole structure, not just the name. But all right, so I'm going to pause for a second for that.
Yeah, no, I've definitely run into that where you have to pin it, essentially. And it's always with those table-driven test cases, it seems like.
Yes. Well, and it's because if you have a table that's driving, then you have to range over the table. If you're ranging over the table, then you need a pointer, you need a way of getting the element of the range. And then you run into those challenges. And then it varies, right? Sometimes it works. It depends on whether you're using pointers. It depends on a number of factors. All right, any questions? Read about that. Yeah, there is a, did someone answer that? Looks like, yeah, great. Sorry, I got distracted by a question that came in. It looked like it was answered. All right, so loops, cool stuff. Loops over closures actually have the same problem, but it's slightly different, right? It's a closure. And so here's the thing. I'm looping over, see this V, it's the range of data. You can see the data here. Here I have a go function. So I'm spinning off threads to print off values, and we'll get 333. It's the same problem. But when we have this problem, we actually have a couple of things we could do. One solution would be V colon equals V. That would work. The other solution would be to actually pass in V here as a parameter to the function that you created. So you could actually pass in the value, which would have to, essentially it does the pass in a value here and then pass in the V here. In order to call that function, it would have to copy the value. So you're essentially copying the value, but in a different mechanism. It's roughly the same thing under the covers. All right, so looping over closures. And I did the demo for that already. All right, another great book. You Are Now Less Dumb. Really, really great book on behavior. That's what I brought to the table tonight. There's links. There's either links in the presentation, 50 Shades of Go. You have these Go coding mistakes. There's one other, but we covered them all under that, which is the Go Common Mistakes Wiki. And that covered essentially the issues with the loops that we just talked about. So I am open to questions, or we could dive into some more code if you want to. I don't have anything more prepared, but I don't mind coding with you live. So why don't we open it up?
Let's see. Any more questions? Feel free to use the chat or the Q&A box if you have anything.
Debugging is twice as hard. Yeah. Well, it also depends. I mean, there are some projects that we have that's almost impossible to load up on one box, which is terrible in and of itself, but it's really hard to debug sometimes, for sure. And then when you're debugging in concurrency issues, that's even more challenging. Okay, yeah, I'm just reading through the chat, so.
Yeah, no, here a question just popped up.
Are you doing any live coding?
Yeah.
Well, I'm open to. So I don't know if it was clear, but my main function right now so far is everything I do right now is open source. I do have a couple of projects I've started reviewing that are internal to the company I'm with, but almost everything I do is open source. So I either write code in the open, or I read issues or pull requests in the open, and make comments or make updates. But I'm totally up for pair programming. If someone wants to grab me for an hour or two, we'll of course schedule that within whatever calendars and stuff, but I'm open to that. Also, if you see here, this bottom one, K8 Slack, I'm there probably every day unless I'm on vacation. So just Ken Sipe, you hit me up there. I'm usually available. Again, I only offer that because no one's made it a scaling issue yet. So, if it does become an issue, then I'll address it, but totally open to having conversations or what have you. Talk about Go tags. You talked about, yeah, you can use tags other than with structs. I didn't even know. So the tags, so there's a couple of really, that might be a whole other talk we might want to do sometime. There's a couple of things that are kind of odd within Go. And one is the tags, and they determine what will be compiled or what will be run or tested. There's also, we could talk through the details of either XML or JSON encoders where we have tags that define how generators will be created, among other things. So sometimes I use the word tags in different ways, so you have to be careful. The context of the tags is sometimes I call those attributes or tags for YAMLs. I sometimes call them tags. I don't know if that's appropriate, but they're certainly metadata for understanding how to process the YAML. Both of them are metadata, frankly. What features do I like in Golang? The refactoring is just so much better in Golang by a long shot. Project setup is also really good in Golang. I can move things around and refactor. The ability to dive into things is actually better. If I were to add a whole nother dependency, let's say, I don't know where I would do that at. Oh, well, I'm in core code right now. If I want to add another dependency, let's say I was going to create maybe some Cobra stuff. The ability to find stuff for me or have it just import it. I don't have that now. Let's go func. Yeah, I guess I'd have to do it on the import. There are some things that are just almost magical within Golang, and it's hard to live without it, actually. I will say VS Code is getting better, and this is where things are a little bit interesting. I so far haven't liked VS Code for Java development because the Java setup is way too hard, and the Go development is actually fairly easy. So for Go, I actually like it a lot. I think VS Code can be better when you get into things like, I want to know who did this line of code here. So it was me 2 days ago, right? I literally get metadata as I'm walking through code. And the diffing on VS Code, I think, is better. I can also get an easy view within VS Code of just what has changed with this particular project, which is outstanding. So when I'm looking at either, when I'm doing PR reviews, I often like VS Code because I'm not going to be refactoring anything. I'm just reviewing. VS Code is phenomenal at reviewing diffs. It's also my default for Go diffs. If I went in here and said git, I forget what I called it now. I should know this, right? Git diff. Maybe it was wdiff. Yeah, that's not it. One of my differs automatically jumps me out to VS Code because it's more complicated. It's probably in one of my aliases. Yeah, it's in there somewhere. So anyway, I think I'm pretty attached to Golang though. When it comes to like I don't know if this is possible. Maybe it's possible. I just haven't looked, but I automatically if I change something and I hit save, it automatically is doing a linter check right now on my save. And then it's like, hey, you screwed this up, dude. So I fix it and then I hit save again. And then it passes the linting. So it actually is integrated into the Golang CI linter. And it's using the linters that I've defined here. They're just automatic. I also prefer VS Code for my Markdown management. The previews on Markdown are really excellent. Same with ASCII doc. And I haven't seen anything that has enticed me to go a different direction. I think it's so much easier to run things with Golang. Like literally it just shows up if it's a main. I don't have to pre-configure anything. In fact, it will automatically configure it when I run it, which is awesome. Same with tests. If I run into tests, I can either run the whole thing or I could run just the test. I find that it's VS Code sometimes gives me that, and it's just unpredictable. Like it'll have a little hover over, and you have to wait for it to show up, and it's just a little bit odd of experience. So yeah, those are my takes. And clearly, I like both of them so much. I use both of them. So, but it helps that I'm working on open source code, and they give me a license. So, but I think I would pay for it if I had to. Unit testing Golang. What is your preference? Yeah. So there's a couple of things I do like with as far as preferences go. I think you'll see them in my own imports, I hope. Not that one, I guess. There's a thing called Testify. Here it is. So we use Testify, which I happen to like a lot. I try to stay away so far from some of the there's a couple of tools out there that I dove into for a bit, like some VDD tools and such, and it just became cumbersome for me. I switch to them when I have to. There's certain projects I work on for which I didn't create them, and I'll use them. But so far, it's pretty generic stuff. When I'm doing Kubernetes stuff, I'm using, of course, their fakes to fake out certain things, and I use Testify. Other than that, we do tend to do a lot of structured unit tests or data-driven, table-driven tests. And it's always a requirement that the first element is a name. So it's a string, it defines the name of the test you're actually running. So you can see that this was a pod test, this one's a namespace test, this one's a custom resource definition test. So there are some nuanced things that are expected. We have a preference for table-driven, but I deviate from that on occasion, and it just depends. I also happen to like, let me see if I can find it in our code somewhere, a golden file. I do tend to like the golden file. So for this, there's a flag for update on your tests, and it will automatically, if the flag was set, we'll run through this code, otherwise it doesn't. And if the flag is set, you mean write the file. So you essentially change the structure of your YAML, and you need to update your test files. When you run the tests with the flag update, it will update them all for you, which is awesome. Otherwise, your normal run is without the update, and it won't update or write. It'll only read and then compare. So whenever you're doing like config files or YAML files, things along those lines, golden file pattern is actually really awesome. I use it quite heavily. There was a time when I was using a lot of, what did you call it? Aeroflow? Yeah, don't remember. I'm sure it's still in there. But it was a file level abstraction. And oh, there it is. There it is, this guy. So Affero. I just remembered the wrong name. But Affero is a file level abstraction, which can be cool. But there's times when it's not. It becomes somewhat of a burden. So what this does, essentially, this particular one, is replace the file system with an in-memory map. And so all files that are written to in-memory. So there's really nothing to clean up, and your tests fail or get destroyed, whatever. There's nothing to clean up. It was all in memory. So those are some things that I use. You know what I miss? So when you ask the question around unit tests, in my Java world, the one test framework I absolutely loved was Spock, which is a groovy test, BDD tester. And I am just such a huge fan of it. I've been speaking on it for more than 10 years now. And still, if I run Java, I always use it. It's just phenomenal. And I would love something like that in the Go. I'd miss it. But you know, to add Go or Groovy is a dynamic language. To add another, a dynamic language component as an extension for tests on Go just doesn't make sense. So I cry a little bit every once in a while. Remember the good old days and drink a beer. And I forget. I drink until I forget. All right. That was all the questions. I'm trying to read through the chats. I don't know if anything was directed.
Oh, you had a couple come in here just last second, and just an FYI, we've got like 15 minutes left on the session. So don't want the mishap of like last month where all of a sudden it just died.
Yeah, I joined a couple of times on that. That was a little bit awkward for sure.
Yeah,
and it was such a great presentation. It was really cool.
Yeah, no, for sure. And Bill kept going. There was lots of interaction, and all of a sudden, my machine actually kind of died, so I wasn't able to extend the session, and it was it was crazy.
Yeah. You know, I'm in St. Louis, and here's the problem. I'm a remote employee. The company I work for is in San Francisco. So anyway, we should plan a lunch sometime. I'd be happy to have a more detailed, let's have a lunch somewhere. I don't care. Westport somewhere is reasonably close. But interfaces in Go. You know, I almost added something to the presentation about interfaces, and I didn't. There is a preference. This would be true in any language, to reduce the surface area, I like to call it, but reduce what an interface can do, what its purpose is, to reduce it to the smallest possible thing. So if you have an interface that has just one function in it, one method defined, there is a Go idiomatic way in Go of what to call that thing, and it should end with ER. So an example would be stringer. Stringer is anything that has a string function that returns a string. But there's other examples just like that. A reader is something that can read. A writer is something that can write. And those sound easy and obvious, but there's other ones, and I can't, off the top of my head, I can't remember what they are. They actually look and sound odd. They're not proper English, but we still call them ers, whatever the is, right? You know, a clienter or something like that. Outside of that, I commonly use interfaces throughout Go, and it's super useful and helpful. You know, it's a little bit odd if you're coming from another language standpoint, because I mean, there are other languages like Go in this way, right? But it uses duck typing, which means, oh, you know what? There is something to show you though. Let me see if we have that in our code. Interface. Dang it. Would it be type? No, that's not what I'm looking for. Where would I have it? I know that I have it. So what I'm looking for is if you have a structure, let's go to our types. Oops. See if it's in here. If you have a structure and you want to ensure that this is super helpful whenever you're using an interface and your structure is intended to adhere to that interface, and that interface in particular is defined by a third party. In other words, you don't control it. So what you tend to do is just define a variable, variable variable underbar. And that's the part that looks weird. Maybe I can search for that. Let me see if I can find it. There we go. Okay, great. So this is an example of it. So here you see var underbar client set dot interface equals, and then you have this client set. And if we were to dive into that, it's a structure and it has some functions in it. I would still do this. What we're saying is this client set interface. So this interface right here, we are defining a variable which is unused, underbar. It's not going to be used by anywhere. And it is assigned to this structure. Man, does that look weird, right? It looks super weird. What does it do? Well, what it does is, in order for this to compile, first of all, this is an underbar because it's a variable we'll never use. So in order to make it to compile, we use the underbar, right? Everybody cool with that? The second part, though, is this underbar is of type this interface. So this is equal to this interface, and it is equal to the newly created client set structure. What does that do? Well, the only way for this to compile is for the client set to fully implement the client set interface. If it doesn't at any time, let's say I do, like the only reason I would do this, if this structure we're defining, this interface we got from a dependency. So when I see this dependency, the likelihood that this would break is someone changed code and they changed the signature of the function that they shouldn't have. So that's step one. Someone in our code changed one of these functions, right? Like this. And they're like, hey, this should take something. And that broke things. That will not compile now. And then they would be forced to change it back. So that's one case. The second place that this would happen is if we did an upgrade, and in the upgrade, we got a new interface, and the interface changed, but our structure no longer has the functions that were newly changed or added. So this will enforce that all of the methods that are defined in this interface are defined within this structure. It has receivers for everything defined in the interface. Does that make sense? So I don't know where that came from. It's out of the blue. It's one of those odd things in Go, for sure. But it's super handy to know about. So hopefully that was useful. Is there a name? I'm gonna call it the Kender. No, I don't know a name. That's why I couldn't search for it. We want a pattern name for that. That'd actually be useful if there was a pattern name, then I could reference it to something, but I don't know of one. Here I am, foolishly just writing code without a name for something, right? We should give it some kind of foreign name though, so. Anyway, all right, I lost my train of thought. Let's focus. I don't know anything about stretch images. I used to do a lot with images in the Linux space, but that was so long ago. There were some really cool libraries there, and I've never seen them duplicated in other platforms, but I don't remember what they were anymore. I wrote a political site some years ago. That's pretty scary, right? This was pre-Obama days, so it was that long ago. It was, I guess, greater than 16 years. But yeah, part of it was taking in images and processing them at the server. So I did a lot of stuff at one point, but I've never done that in the Go world, so wouldn't be able to help you. Oh, but you know what would be worth it though is, let's see here. Awesome. If you search for Awesome Go, you'll come up with a number of sites. Here's my search. And I don't know which one was the authority, which is weird, but this is just an amazing list of like libraries. And then this person took it and went a step further and added in stars for the projects as well. But if you're looking for like image processing, I'm sure you're going to find some pretty cool things in here. So there's a bunch of stuff just on images. But you know, I'm not really answering the question. What I'm trying to do is say, hey, hopefully, if you know about this site, you can find the things you're looking for. Yeah. So Awesome Go. Name of a Java test framework again? Oh, the name of it. Great question. Was Spock test framework. It's this guy. And, oh, nice. Okay. Anyway, I have a number of workshops on that too. If you either search my GitHub so I have two. I have Ken Sipe and I also have Code Mentor. But if you go out there, I'm sure you're going to find them. I'm going to have some stuff on Spock if that's what you're interested in. I did something on Spock at JavaOne like a few years ago, and this has been updated last year, well, I guess a year ago, but yep. And if you have questions or thoughts, let me know. Oh, the presentation on this one though, did we say where that was? Oh, it was on my Code Mentor one, wasn't it?
Yeah, no, I mentioned I'd put that into the show notes, but yeah, I don't know if you showed it.
Here it is. It's right there.
Oh, okay.
So go to the Code Mentor, CODE Mentor, Go Mistakes. If you just go to Code Mentor, I'm sure you'll find it there as well. But the slides are right there. Slides, and then all the references down here, and all the code we were messing with. So, and then even I mentioned like the Go Common Mistakes Wiki. I just laid reference to it and didn't give it away, but this is the loop iterations, Go routine variables, and so that could be grown out a little bit. But this 50 Shades of Go is actually excellent. Beginners, intermediates, more advanced. It goes all over the map. It's quite a few of them.
Oh. No, that was awesome. Yeah, I'm going to definitely have to hook into that the Golang CLI, or that linter, the Uber linter.
Yeah. The one linter to rule them all.
Yeah, no, for sure. Awesome. Okay. And it looks like, yeah, so we got those and we've got like 5 minutes left. So I'm going to switch over here, go through my last slides.
Oh, take it. How can I give it up?
I really appreciate this. It was great. Let's see. All right. There we go. All right. There we go. All right. Now I can go through the slides that I worked so hard to create and everything. So yeah. So again, Ken, yeah, thank you so much for doing this presentation. It was great. Really, it was.
Absolutely.
And then, yeah, just for everybody that's left, we'd appreciate any kind of feedback that you might have, suggestions for other topics, speakers even, and it could be Go related. It can be CNCF related. So because that CNCF landscape is huge. I mean, it's just growing incredibly fast these days. So, yeah, there's all kinds of additions to the sandbox, which I'm really actually kind of stoked about. I need to go through a lot of that stuff. But yeah, and as well as now that we have our little domain there, I have a shortcut to repo. So you can get to that. I'm going to set it up in GitHub so that, if you want to make a suggestion or whatever, you can just create and open up an issue and then be able to submit it that way. So might make it a little bit easier to get that information to us. And then, of course, as we continue to social distance, don't isolate alone. We kind of have our home in Slack at the STL Tech Slack. Think you have to just log into that, and I believe get an invite, if I remember correctly, that way. But yeah, they'd let everybody in. So, so anyway, yeah, feel free to get in there. It's not a whole lot of chatter in there, so yeah, hopefully won't miss you. And yeah, we took care of the giveaways. I think we had enough people in here, or just enough people, that we could give away all the licenses. A nice 1-year license of Golang, or actually it's for any JetBrains product you can use that license for. But obviously we're kind of leaning more towards Golang. So it's good stuff. And as far as the next month's meeting, we have October 28th. We don't actually have a speaker lined up just yet. So if anybody's interested, I see we have a couple of celebrities also in the audience here. We've got Jonathan on there, and then also Mark Volkman. These guys they've been talking on the circuits and such as well. So I know I've heard talks from both of them. So, we could have a session talking about Svelte, if I remember that correctly, or WebAssembly maybe. And then Jonathan, I know you do a lot of the stuff with Docker, so that would be awesome. So anyway, hint, hint, nudge, nudge, wink, wink. So anyway, again, thank you everybody for joining us. That's all we've got. Please do follow us on Twitter, or just keep up with us. We'll be around next month again. So we'll look forward to seeing everybody. Hopefully everybody stays healthy and safe, and we'll look forward to seeing you all again. So thank you. Have a good night.